All right, for these set of problems, we need to figure out which ones converge, and that way we can then pick out which ones would diverge. So here with our series, there's the divergence. The ones that would diverge or converge would be whenever, let's see, closely related to this one would be 1 over n squared. We know this converges, and compared to the first one, we would also know that that converges. So our answer can't be 1. If we look at option 2 is a geometric series, and we know that if that ratio, in other words, what we're multiplying by to get to the next term, is that absolute value is less than 1, then we also have convergence. Well, looking at this one, notice we have 6 over 7. That's going to be our ratio. And we do see that that is less than 1. So this series would also converge. For the third one, notice that we do have -1 to the k power. So this would be an alternating series. Each fraction is decreasing in value. So here we would have our alternating series, and so therefore that one also converges. So notice all of these do converge, so which series diverged? Well, none of those diverged. Okay, for this problem we need to find the slope of the tangent line, and so let's go ahead and find the derivative of our original function that we're given. So we're going to have to do the derivative of this portion first, which is our product rule. So we have first times the derivative of the second plus the second times the derivative of the first, and then it's all over xy, and then all of that is equal to 1. Now we need this value when x is 1, but we were not given a value for y, so we will have to go back to our original function, substitute in 1, so that means that natural log of y is 1, so that means y is going to have to be equal to e. So now that we have both parts, we can finish solving this. So let's go ahead and sub in. So we're going to have 1 times dy dx plus e all over e equals 1. And so solving this, we have dy dx plus e is equal to e, and it looks like our slope is going to be equal to 0, which is going to be answer choice A. Alright, for this problem it looks strange and they want us to find the derivative here. So if we take the derivative of e to the stuff, again we would say that's stuff prime, so f prime at x times e to the stuff, and then that's equal to 2x. We're solving for f prime at x, so let's divide both sides by e to the f at x. And notice we have something strange. It doesn't look like any of our answer choices, so we have to keep trying to simplify what we can here. And it looks like we're going to have f prime at x equal to, we have 2x, but what is e raised to the f at x? We were told originally that was 1 plus x squared. So that looks like it's going to be answer choice B. Okay, number 20 is another particle motion problem. And so we're given acceleration and we've got to go back and find the position. So our first step would be to integrate our given acceleration equation of e to the -2 times t dt. And so that gives us our velocity function. And whenever I integrate this, I'm going to get -1/2 e to the -2 times t plus our constant c. Okay, using our initial conditions, we see that at time 0, the velocity of the particle is 5/2. So I have 5/2 equals -1/2 e to the 0 power plus c. And notice when we solve this equation, we will get 3 for our constant c. And so now we can go ahead and finish our velocity function. So our velocity function, negative 1/2 e to the negative 2 times t plus 3. Again, we're still looking for our position function, so we're going to have to integrate one more time. And so if we integrate our velocity, which means we'll have to integrate this other side. So again, and we're probably getting pretty close to being able to pick out our answer choice without actually having to finish this entire problem. Notice we have our position function is equal to, and again, once we go through here, we would get 1/4 e to the negative 2 times t plus 3t plus c, and I think that's probably enough information to go ahead and pick out our answer choice. Notice looking at it, we are probably going to get answer choice E. Now we could continue on the problem, but it's really not necessary because we have enough information to pick out that final answer. Okay, so for number 21, we're going to have to do our quotient rule, and so we have to be careful with those exponents. So our derivative dy dx is going to be the bottom, so we have 2x plus 1 to the 1/4 times the derivative of the top, and the derivative of the top we have to do our chain rule, so we have 1/3 times x squared plus 8 raised to the negative 2/3, and that is times 2x. Okay, so there's the bottom times the derivative of the top, and then minus, and then we have to do the bottom, so x squared plus 8, or I'm sorry, the top times the derivative of the bottom, so 1/4 times, not e, good gracious, 2x plus 1, all raised to the negative 3/4. This is the never-ending problem. Negative 3/4 times 2. Don't forget to multiply by the inside. And then it is all over, so again, every bit of this is all over, and then the bottom squared. So we're going to have 2x plus 1 raised to the 1/4, but then that is all squared. Okay, now let's go ahead and we want to know, well, what is this value at 0? So instead of doing a lot of algebra here, all we have to do is plug in 0 for x and work out. So if we're going to do that, then notice a lot of things should cancel out if we're plugging in a 0 for x. Notice from the first grouping, if I plug in an x, and I'm going to change color so we can see, if I plug in an x right here, well, all of that inside goes to 0, and including the outside, because it's 0 times all that. So this really ends up being 0 minus, and then over on the other side, let's go ahead and plug in 0 there, and so let's see, we would have a 0 plugged in here, but then that's really going to go to a 1. And after we multiply and work out all of this, it looks like we'll end up probably with a 1. So we're going to have all of that. So 0 minus 1, all of that just to condense down all over 1. My gracious. So let's see, that's just going to end up being negative 1, which is answer choice A. All right, so here we're looking for the interval in which f is decreasing, and really the fastest way to do that is to find where f prime is negative, because if f prime is negative, we know our original function is decreasing. So our derivative, let's work through that derivative. We have the first times the derivative of the second plus the second times the derivative of the first. And we need to find our critical point, so we'll set that derivative equal to 0 and factor, and it looks like we have a common factor of x and e to the x, And once I factor that out, it looks like we'll have an x plus 2 left over. And again, we are looking for those critical points so that we can find where we change from increasing to decreasing. So 0 equals x times e to the x, or 0 equals x plus 2. So it looks like we have two possibilities, that x equals 0 and x equals negative 2. Right, so let's do a number line, and we have 0 and we have a negative 2. Oops, I thought we had positive 2. Okay, so negative 2. And let's pick some values, and we'll go back and look here in the factored form. So the first value we can choose would be like negative 3. So if we choose negative 3 and plug in, so we would have a negative value on the outside, and then on the inside we would also have a negative, so we have a positive value there. So between negative 2 and 0, let's pick a test point of negative 1. And again, the same idea, we would have a negative times a positive this time, so we have a negative. And then we see on the other side of 0, we would have positive. So inside this interval is where the derivative is negative, therefore that's where our original function is decreasing. So it looks like we should get answer choice B. With number 23, we need to find the length of the curve determined by our two equations. And so this is a pretty straightforward problem. We do need to find our derivative at x, so dx dt, which is going to give us 2 times t. And then we also need to do the same for the y, so dy dt, and that's just going to be a 1. And now we plug into our formula, and we were told we need to find this from times 0 to 4, and it's the square root of dx dt squared, so we have our 2t all squared plus our dy dt squared. And so it looks like we're going to get answer choice D. And this problem is a little bit different. You are told that the functions f and g are differentiable, therefore we know they are continuous for all real numbers, and you're told that g at x is not 0 and x is not 0. But you're told that the limits of the two are equal to 0. So let's think about this. We have the limit as x approaches 0, and we're wanting to find this, which is going to be f at x over g at x. And notice that we're going to get 0 over 0. So we really are looking at L'Hopital's rule. And with L'Hopital's rule, it says we can approximate the value of this limit with our derivatives. So really that limit is going to be the same thing as if I take the derivative of the top over the derivative of the bottom. And notice that's going to be answer choice C. Okay, so for this problem, we have to find the slope of the tangent line. And we have to find it, though. Notice everything is in parametric form, but we're asked about where the point x equals 3. So I would need to do some kind of conversions here so that I am talking about rectangular. So let's go through and eliminate our parameter t. And so we're given that x equals e raised to the t power. So I'm going to take that and try to make y talk about x. So y equals, and we have t over, well, e to the negative t. So this is really going to be y equals t over x. But then we need to, still we need to solve and get rid of t. So we could also rearrange this equation here and do the natural log of both sides. So I have the natural log of x equals the natural log of e raised to the t power, which means that the natural log of x is equal to t. So now I can go back over to our equation and rewrite it. and we should have it now in rectangular form. So I have y equals, and that's really 1 over x times the natural log of x, which would be the natural log of x all over x. So now we need to do the derivative here because we need the slope of that tangent line at x equals 3. So we have dy dx equals, and we're going to have to do the quotient rule. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. And now we substitute in, or we find the slope dy dx when x is 3. And this is a calculator problem. And we end up with 1 minus the natural log of 3 all over 9. And when you type that in your calculator, it looks like you should get answer choice D. Okay, so for number 26, we're told that y equals, in arctan, a lot of times now you would see that as here the inverse tangent of e to the 2x, and we want to know, well, what is the derivative? Now we do have a formula that says if we take the derivative of the inverse tangent of x, then we're going to get x prime over 1 plus x squared. So we're going to apply that formula here, and so our dy dx equals, so I know I'm going to have a 1 plus x squared, but notice what's inside here. So it's e to the 2x all squared over the derivative. Well, the derivative of e to the 2x is 2e to the 2x. And so it looks like we should get answer choice B. Okay, for this problem, we are finding the interval of convergence, which means we need to apply our ratio test. So our ratio test, we're going to look at the n plus first term over the nth term, and we're going to have our limit as n approaches infinity of the absolute value, and our n plus first term, so we're going to have x minus 1 to the n plus 1 over 3 to the n plus 1 times, and because we are dividing by this term, so therefore we need to multiply by the reciprocal, so 3n over x minus 1 to the nth, and all of that has to stay less than 1 for us to converge. And so working this on out, and a lot of times you should be setting up something that will cancel out quite nicely. And so we have absolute value on top. We're going to have x minus 1 over, and notice in the bottom everything cancels but the 3, and that has to be less than 1. So that tells me then that I have the absolute value of x minus 1 all over 3 is less than 1. So now we have to solve this inequality, which should turn into a compound inequality. So we have, I'm going to go ahead and multiply both sides by 3 and set up our equations here, and positive 3. So it looks like we have negative 2 is less than x is greater than 4. So looking at our answer choices, that narrows down our answer choices to C or D. And notice 4 is not included in either one, so the only point or endpoint that we need to test is negative 2. So let's test x equals negative 2. So we'll go back into the original and let x be negative 2. And we need to see if this converges or diverges. So we have n starts at 0 to infinity, and if we plug in negative 2 minus 1 is negative 3 to the nth power over 3 to the nth, and we can move around this a little bit and try to see and reduce down, because since both are to the nth power, we can rewrite this to be n starts at 0 to infinity of negative 3 over 3 raised to the nth power. And from this, we see that this should diverge, so that endpoint would not be included. So my answer choice for 27 is C. Okay, with 28, again, we have particle motion. Yay, fun problems. And let's see, if the particle moves in the xy plane so that the time t greater than 0, we have the position vector. And then from that position vector, we need to find the velocity vector. So we have our position vector is at natural log of t squared plus 2 times t. And let's see, n at 2t squared. And again, that is the position. So for the velocity vector, you should end up with, let's see, t squared plus 2t. We take the derivative there. We're going to get 2 times t plus 2 all over t squared plus 2 times t. And then over on the other side, we're going to have 4 times t. So we have here our velocity vector, and now we need to find this when t is 2. And so we need to go substitute in our 2, and it looks like we're going to get 6 in the numerator over plugging in 2 in the denominator. We're going to have 4 plus 4, 6 over 8, comma, and then for the other side we would have 8. So let's see, which answer choice does that look like? It is answer choice A. Okay, number 29 is an integration by parts problem. And so I'm going to let you, because we have, I think we called it sunshine minus voodoo. So UV minus the integral, that's your sunshine, minus VDU, which sounds like voodoo. So sunshine minus voodoo. So our U value here is going to be X. So automatically our du is going to be dx, which is great. We need that to happen. dv would then have to be secant squared x, and if we integrate dv, we get v, which is going to turn into tangent x. And so now we're going to plug into our sunshine. So uv, so u times v, so I have x times tangent x minus the integral of v tangent x du, which is dx. So here we have x times tangent x minus, and if I integrate tangent x, then that's going to be negative natural log absolute value of cosine of x. Either know that formula or divide this up and make it sine over cosine and do a u sub. That will also generate this for you. And so, and of course our plus c, we can't forget that. That would be tragic. So answer choice, it looks like it's going to be E after we clear up those negatives. Okay, number 30, we're trying to find the volume by rotating our solid figure about the x-axis. And our curve that we're looking at is y equals secant x. Now, let's see. We need to do a sketch, and cosine does something like this, and then secant is going to be sitting on top of this. So here, so our secant curve is going to look something like that. And so let's see, we're going to be cutting that. Let's draw a little bit of a better picture, but there's the idea of it, because being the reciprocal of cosine, it's going to sit on top of those cosine curves. So we have an idea of how it's going to be turning. And so let's see. Here again, we're going to sketch it. And so secant is going to be turned up something like this. There's our secant x. But then we're also going to bound it on the right side by x equals pi over 3. So we're going to cut this here at x equals pi over 3. And so we see that our solid is flush on our axis of rotation, so that makes it a little bit easier for us. We won't have to subtract out anything. And so our volume equals, and we have our pi, and we're going to integrate from x value to x value, so from 0 to pi over 3. of our function, which is secant x squared dx. And again, we're able just to jump straight to our big radius squared just simply because we are flush on our axis of rotation. So that means our volume is pi times, if we integrate secant squared, we get tangent x, and we're going to evaluate this from 0 to pi over 3. So evaluating, we have pi times, and tangent of pi over 3, that's going to be the square root of 3 minus tangent at 0 is 0. So notice we end up with pi times the square root of 3. So that should be answer choice C.